Now the last part that I will go over today is basically the assignment operator. So what I'm gonna do is to clear all my variables and then to clear my command window. Basically, guys, if I need to define, let's say x is equal to 3. So what happens in my workspace? Whenever you click on enter, you will have x defined in your workspace as 3. Then what if I do this? X is equal to x plus 2. So I did not click enter yet, alright? So what do you think, guys, will happen here? In fact, Matlab will take this equal sign and divide this operation into two sides. The left side will be the variable. So the left side of the equal sign will always be the variable that will include the answer of the right side. So the right side is what here? It is x plus 2. If x wasn't defined in my workspace, Matlab will of course give me an error. Now since x here is defined as 3, then x plus 2 will be equal to 5. And then Matlab will put the value of x plus 2, which is 5, inside a variable called x, which is here a predefined value that is equal to 3. If x is not previously defined, then Matlab will define a new variable called by this name and put inside it a value of 5. Now since Matlab here has a predefined value that is equal to 3, then Matlab will update this variable by the new value. So basically, guys, this assignment operator will always put the value after the equal sign to the variable before the equal sign. So the value after the equal sign to the variable before the equal sign. So whenever I click enter, x here will be updated by the recent value of the assignment operator, which is here the equal sign. So guys, you can use the predefined variable in your operation and put it inside the same variable, which is here x. But you should know, guys, that the previous value will vanish and now you will have a more recent value, which is x plus 2. Now, guys, I want you to know that inside the library of Matlab, there is what is called built-in function. Built-in functions means like the calculator. You can see in your calculator that you have radical sign, all right? So you can use this radical sign like radical 4, it will give you 2. Now here inside Matlab, I also have some built-in functions that are commonly used in math. Like what? Like the square root. The square root is given as sqrt. So I'm going to use this sqrt for x. What is the square root of x? I'm going to click enter without a semicolon to see it on my command window. Basically, the square root of 5 is 2.2361, and this will be saved in ans because I did not define a variable here before sqrt. So ans here is equal to 2.2361. And also, guys, you should know that inside Matlab there is some predefined constants that we can use, like pi. If I put pi and then click enter, this means that I'm urging Matlab to give me the value of pi. Like, for example, I can put x with an enter, so x is equal to 5. Now, pi is defined in Matlab, and it is equal to 3.1416. Now, for example, I, as we know, I is the complex number that is equal to what? It is equal to some real zero part with an imaginary I, and now I, we know that I squared, so if I do I squared is equal to minus 1. So guys, I is also defined in your Matlab library as well as J. However, if you define I as, for example, 10, then whenever you use I, now I is 10. If you did not define I and the J will be the complex number. So guys, put on your mind that I cannot use any variable without defining it, except the values that are already defined in your Matlab library, like pi, pi, and like I and the j. Now, if you define I and j in your command window, the MATLAB will stick to these values, to the defined I and j. If you did not define I and j in your command window, the MATLAB will use the complex numbers of I and j. Okay? I also have what is called inf. Inf means infinity. And NaN means not a number. So it is not a number. Like what? If I wanna divide 10 by, if I wanna divide 0 by 0, 0 by 0 is not a number. If I wanna divide 10 by 0, 10 by 0 is infinity. So we have all of these constants inside MATLAB Live. Now guys, I want you to solve this problem. Okay, so this is a very basic problem that we can solve on MATLAB. I will remove the solution for now. Okay, so basically I have that the volume of the circular cylinder is pi r squared times h. I need, given a radius r and the height h, so we know the radius r and the height h, we can find v of a cylinder. I need to find the radius of another cylinder with the same height but with the volume 20% greater. Okay, so guys, I need to find the radius that has a 20% greater volume than the volume of the cylinder that I need to define there. I need to define its height and its radius. So let's do it. And here with a note that we should use a semicolon to remove the screen printing. So I'm gonna assume that r is equal to 8 and h is equal to 15. Clear all CLC. R is equal to 8 and h is equal to 15. How I'm gonna find the volume? I know that the volume is equal to pi. So why can I use pi? Because pi is already defined in the library of MATLAB as 3.14. Pi r squared times h. So this is the volume. If I click enter, you can see the volume on the workspace. It is 3.01 times 10 to the power 3. Now I need to find a new radius of a new cylinder that has a volume V equal to the old V plus 20% of it, which means 1.2 times V. So what I'm gonna do, I can of course define another volume, V2. So let's do the simplest way. I will define V2 as V plus 0.2 times V. Guys, you cannot say 0.2 times V. If you use this and then you click enter, MATLAB will tell you that there is unexpected MATLAB expression. So if I go page up and then add the star, now MATLAB will understand what is V2. So V2 is V plus 0.2 times V. Now V2 is defined in your workspace as 3.6 times 10 to the power 3. How can I find R2 from V2? Basically, I can do V over pi times h, and then I can do the square root of the value. So it is SQRT of V2 over pi times h. So why I'm using the parentheses here? Because it has the same precedence of our calculator. So if you remove these two parentheses here, then MATLAB will do V2 over pi and multiply the answer by h. In fact, it is V2 over the multiplication of pi times h. So this is R2. You can find it here. Now what if I don't want to define V2 and R2? Instead, I'm going to modify V and R to have the new values. So what I'm going to do is to define the new V as the old V plus 0.2 of this V. Now V will change. It will have the same value as V2. So you can see it here. Take a look on the workspace. And then I'm going to define the new R as SQRT of this V over pi times H. So of course the new R will be replaced and then the value will be 8.7636. So this is for today for MATLAB. I want you guys to practice all of them on your MATLAB, on your personal computer. And then next week we will go over the arrays and matrices on MATLAB. Thank you.